Mars might seem easy to accomplish now that we have sent so many probes and rovers there. We have the knowledge and technology to get there, but it's still unfortunately still very dangerous and very expensive to get there. To get there, you would need a rocket or some other form of transportation. My personal favorite, the rocket, would work very well. While William and everyone else are trying to figure out the interplanet hyperdrive, I stick to something I know would work. The first stage is to lift your rocket off the ground into a reasonable orbit. It needs to be pretty big in order for it to make it out the atmosphere. It also needs a gimbal in the engine to control its direction. The second stage is to get into a stable orbit around the Earth and set your trajectory to Mars. The third stage, the power you will need to thrust your way into the course to Mars. The spare supply module will have basic gear and resources: oxygen, food, water, clothes, building tools, metal supply, and entertainment for the incredibly long journey. The command module is responsible for many functions. The most basic include rotation control system or RCS thrusters, radial or stacked engines for landing, a heat shield for re-entry, landing gear, and a hatch. You wouldn't expect that, but you do actually need a way to get out of the ship. There are many more functions of the command module, but they're very complicated and it would take a very long time to go over and explain everything. When you have a good launch window to get to Mars, you would want to launch in a steady orbit and then set a trajectory. On an average, depending on the orbit, it can take anywhere from 6 months to a whole year in space just flying to Mars. That's why there's also entertainment on the spacecraft to keep the crew entertained for the long journey. So now on the way to Mars, sometimes you have to correct the course to set your angle and trajectory on a close encounter. But if the pre-orbit is near perfect, there would be no need to correct the current route. If you're near the planet, you must ditch the storage module for a re-entry, because it's not protected by the heat shield unlike the capsule. During re-entry, the heat shield is what protects the command module from burning up. That's why you must ditch the storage module, so the heat shield doesn't crack and explode onto the command module. Now that you've entered the atmosphere, you set a spot to land on the surface and then set up the base. Now the command module storage will have tools and resources to build the base as well. Here is a base I built for the demonstration. The exterior windows are made of tinted ballistic glass for safety and pressure holds. It has big enough space to hold some of the following: medical room, bedroom, farming room, greenery room for oxygen, the outside has features such as solar panels and a water mine. Well, water doesn't roam on the surface, only on the subsurface, so you can extract it. Now it's still being built here, and that's because we only came to Mars with a certain amount of metal supply. We would harvest most of the metal off the planet, and from asteroids, which contain thousands of rare and rich metals and rock from distant stars. So you can harvest them and bring the ore down to the base to use. After you are pretty much finished all your steps to live there and sustain a proper life, even with extra metal you can go back, or you can explore the planet and build on elsewhere in the lands of the Red Planet. And extra details of planet and mission. So how much would this cost? Well, it would cost around $3 to $4 billion because of all the fuel and hull we're using for the rocket to get to Mars. Now, what is the average temperature? The average temperature today on the equator can reach between minus 60 to 70 degrees. Average night temperature can plummet to around minus 100 degrees. What are some dangers on Mars? Well, most nearly of all the dangers are storms. They can take someone out if they're standing outside. Most common storms are sandstorms. Sometimes if they're really bad, it can cover someone in sand if they stand in the same place. But most sandstorms are very weak and only have a slight breeze. Other details on my base. Well, the outside braces along the ballistic glass is made of titanium alloy that is very strong and is used for most average spacecraft. The inside has some sprinklers in case there was a fire. What is the atmosphere made of? Well, there are a lot of substances in the thick atmosphere area. Here are all of them. 0.5% of carbon monoxide, which can kill someone if a lot of it's inhaled. 0.44% of oxygen, 1.9% of nitrogen, 2% of argon, and 95.2% of carbon dioxide. How long would I stay there? Well, I would say about 5 years if it's possible. Then I would build a rocket to go back to Earth with some spare metal and resources. That's how I would get to Mars for my extreme environment and live there. I hope you all enjoyed. I certainly did making this video. This simulator I used is called Kerbal Space Program. The video has some lag in it. I'm sorry, I just can't handle so much rendering with the game and the recording, so it doesn't act perfect as it would. Anyways, like I was saying, I hope you enjoyed watching my project, and I will see you later.